Yes, it is possible to run the load side of a ground fault circuit interrupter GFCI mounted on the side of a panel and some travelers for a three-way switch through the panel to get to the loads. This is how you would do it. Firstly, install the GFCI on the side of the panel. Secondly, connect the line side of the GFCI to the circuit breaker in the panel. Thirdly, connect the load side of the GFCI to a junction box in the panel. Fourthly, run number 12 single conductors in electrical metallic tubing N from the junction box to the loads. Fifthly, connect the travelers for the three-way switch to the junction box in the panel. This will allow you to control the loads with the GFCI and the three-way switch. Make sure that the GFCI is rated for the amperage of the loads that you will be connecting to it. Make sure that the EMT is properly supported and grounded. Make sure that all of the connections are tight and secure. This type of installation is not common, but it is allowed by the National Electrical Code (NEC). It is important to note that this type of installation should only be performed by a qualified electrician. When installing a GFCI, understanding its function is essential. A GFCI is designed to protect people from electrical shock by monitoring the current flowing in the circuit. It compares the amount of current going to a device with the amount of current returning. If there is a difference of even a few milliamperes, it indicates that current is leaking somewhere, possibly through a person. The GFCI will then trip, quickly cutting off the power to prevent a dangerous shock. A three-way switch, on the other hand, allows you to control a light fixture from two different locations. This is commonly used in hallways, stairways, and large rooms. The three-way switch circuit uses two traveler wires that run between the two switches, along with a common wire at each switch. The switches redirect the current flow through the traveler wires to turn the light on or off from either location. Using number 12 American wire gauge (AUG) single conductors in EMT offers several advantages, particularly in an industrial environment. Number 12 AWG wire is suitable for circuits with a current rating of up to 20 amps, which is typical for many lighting and general-purpose circuits. The single conductor construction means that each wire is insulated separately, providing an extra layer of protection against shorts and ground faults. EMT, a type of metal conduit, provides excellent physical protection for the wires, shielding them from damage caused by impacts, abrasion, and moisture. EMT also acts as an equipment grounding conductor when properly installed, providing a path for fault current to return to the source, helping to trip the circuit breaker quickly in the event of a ground fault. When routing the wires through the electrical panel, it is crucial to follow the NEC guidelines for safe and proper installation. The panel is the central distribution point for electricity in the building, so any wiring modifications must be done carefully to avoid creating hazards. Firstly, always de-energize the circuit breaker that feeds the panel before working inside it. This will prevent accidental electrical shock. Secondly, use appropriate fittings and connectors to secure the EMT to the panel and to the junction box inside the panel. These fittings must be listed for use with EMT and must provide a tight, reliable connection. Thirdly, when running the wires through the panel, avoid overcrowding the conductors. The NEC specifies fill limits for conduit and wireways to prevent overheating and insulation damage. Fourthly, maintain proper separation between the line voltage wiring and low voltage wiring, such as control circuits or communication cables. This will minimize the risk of interference and ensure reliable operation of the equipment. Fifthly, properly ground the EMT system by connecting it to the panel's grounding bus bar. This will provide a low impedance path for fault current to return to the source, helping to trip the circuit breaker quickly in the event of a ground fault. In addition to these general guidelines, there are specific considerations for running the GFCI load wires and the three-way switch travelers through the panel. For the GFCI load wires, it is important to ensure that the GFCI is properly rated for the load it will be serving. The GFCI's current rating must be equal to or greater than the ampacity of the circuit breaker protecting the circuit. Also, the GFCI must be installed in a readily accessible location as required by the NEC. For the three-way switch travelers, it is important to identify the correct wires and terminals. The travelers are typically identified by their color, which is usually red or orange. The common terminal on each switch is typically identified by a different color screw, which is usually black. When connecting the travelers to the junction box in the panel, be sure to maintain the correct polarity. The traveler wires must be connected to the corresponding terminals on the two switches. Failure to do so can result in the switch not working properly or creating a short circuit. When making the connections in a junction box, use appropriately sized wire connectors that are listed for use with the type of wire being used. The connectors must be properly tightened to ensure a secure and reliable connection. Also, be sure to leave enough slack in the wires to allow for easy maintenance and future modifications. After completing the wiring, thoroughly test the GFCI and the three-way switch to ensure that they are working properly. The GFCI can be tested by pressing the test button on the device. The three-way switch can be tested by turning the light on and off from both switch locations. If either the GFCI or the three-way switch does not work properly, carefully recheck the wiring and connections. If the problem persists, consult with a qualified electrician. It is crucial to understand the NEC requirements for grounding and bonding. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to return to the source. Bonding is the process of connecting different metal parts together to create a continuous electrical path. Grounding and bonding are essential for electrical safety because they help to minimize the risk of electrical shock and fire. The NEC specifies detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods of connecting grounding conductors to equipment, and the requirements for grounding electrodes. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. In addition to the NEC requirements, there may be local codes and regulations that apply to electrical installations. It is important to check with the local building department to determine what codes and regulations are in effect in your area. When working with electricity, always use appropriate personal protective equipment, PPE. This includes safety glasses, rubber gloves, and insulated tools. Also, be aware of the potential hazards of electricity and take precautions to avoid electrical shock. Never work on live electrical circuits unless absolutely necessary, and always to energize the circuit breaker before working on any electrical equipment. If you are not comfortable working with electricity, consult with a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. The NEC is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding and bonding, and equipment installation. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes. The NEC is available for purchase from the National Fire Protection Association, NFPA. It can also be accessed online through various subscription services. Familiarizing yourself with the NEC is essential for anyone who works with electricity. It will help you to understand the requirements for safe and proper electrical installations. In the context of an industrial environment, additional considerations may be necessary. Industrial facilities often have more demanding electrical requirements than residential or commercial buildings. For example, industrial facilities may have higher voltage systems, larger loads, and more complex control systems. They may also be subject to more stringent safety regulations. When designing and installing electrical systems in an industrial facility, it is important to take these factors into account. The electrical system must be able to handle the demands of the facility, and it must be designed and installed in accordance with all applicable codes and regulations. In addition to the technical aspects of the installation, it is also important to consider the human factors. Electrical work can be physically demanding, and it is important to provide workers with the necessary training and equipment to perform their jobs safely. Also, it is important to create a culture of safety in the workplace where workers are encouraged to report hazards and to follow safe work practices. By taking these factors into account, you can help to ensure that electrical installations in industrial facilities are safe and reliable. Remember to always consult the latest edition of the NEC and local codes for specific requirements and guidelines. Electrical codes and standards are constantly evolving, and it is important to stay up to date on the latest changes. Also, it is always a good idea to consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical installations. They can provide expert advice and guidance to help you ensure that your electrical systems are safe and reliable. Before starting any electrical work, it's important to plan the entire project. This includes determining the size and type of wire needed, the location of outlets and switches, and the route of the wiring. A well-planned project will save time and money in the long run. It will also help to ensure that the installation is done correctly and safely. When working with electrical wires, it's important to use the correct size and type of wire for the application. The size of the wire is determined by the amount of current it will be carrying. The type of wire is determined by the environment in which it will be used. Using the wrong size or type of wire can create a fire hazard. Electrical boxes are used to protect electrical connections and to provide a mounting point for outlets and switches. There are many different types of electrical boxes available, so it's important to choose the right type for the application. Electrical boxes must be properly grounded to prevent electrical shock. Outlets and switches are used to control the flow of electricity to appliances and lights. There are many different types of outlets and switches available, so it's important to choose the right type for the application. Outlets and switches must be properly grounded to prevent electrical shock. Electrical circuits are protected by circuit breakers or fuses. Circuit breakers and fuses are designed to trip or blow if the circuit is overloaded. This prevents the wiring from overheating and causing a fire. It's important to use the correct size circuit breaker or fuse for the circuit. Electrical work can be dangerous, so it's important to take precautions to protect yourself from electrical shock. Always to energize the circuit before working on any electrical equipment. Wear rubber gloves and safety glasses. Use insulated tools. Never work on wet surfaces. When working with electricity, it's important to follow all applicable codes and regulations. The NEC is the primary code for electrical installations in the United States. Local codes may also apply. It's important to be familiar with these codes before starting any electrical work. If you're not comfortable working with electricity, it's best to hire a qualified electrician. Electrical work can be dangerous, and it's important to have it done correctly. An electrician has the training and experience to safely and properly install electrical systems. They can also help you to ensure that your electrical system meets all applicable codes and regulations. Always remember to double-check all connections before energizing a circuit. Loose connections can cause arcing, which can lead to fires. Use a Torx screwdriver to ensure that all connections are properly tightened. Label all circuits in the electrical panel. This will make it easier to identify the correct circuit breaker when troubleshooting problems. Use a permanent marker to label the circuits clearly and legibly. Keep the electrical panel clean and organized. Remove any debris or clutter that could interfere with the operation of the circuit breakers. A clean and organized panel is easier to inspect and maintain. Periodically inspect the electrical system for any signs of damage or wear. Look for cracked or frayed wires, loose connections, and corroded components. If you find any problems, have them repaired immediately. Regular maintenance can help to prevent electrical problems and ensure the safety of the electrical system. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Electricity is a powerful force, and it's important to respect its potential dangers. Never take chances when working with electricity. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before starting any electrical work. By following these safety tips, you can help to prevent electrical accidents and ensure the safety of yourself and others.